Hey, what's up guys? Welcome to my vlog. And today we'll be talking about a certain topic. It is super node analysis. So without further ado, let's go to my partner's room and I will see you guys in a bit. Hey Rugen, catch you or not? Hey.
No, coming. What's up?
Hey, you ready to do our ECF video or not?
Yeah, yo.
Okay. Okay, Rugen. So in our vlog today, right, our topic is about supernodal analysis.
Yes.
So can you please enlighten me?
Supernodal analysis is just a theory that we use to solve a calculation in a circuit. So in the circuit theory, a supernode is just a theoretical construct that can be used to solve a circuit. Let me show you an example. So here the question asks us to find the node voltage. So here, as you can see, the power supply 12 voltage. We will be using a supernode theory. Here, this supernode construct circuit, the voltage source, I've removed it and made it a voltage point. So at this point, we can assume this as just a circuit without the voltage source, and we will solve it. So first of all, to get the first equation, we'll be using Kirchhoff's current law. So here Kirchhoff's current law suggests that it's the sum of current leaving is equals to the sum of current entering a node. So here I'm using that supernode. So I plus I2 plus I3 plus 4 is equals to 6 plus I3. So for I1, since we don't have the I1 and I2 value, we'll be using the formula of I equals to V over R. So we're getting V1 over 4 plus V2 over 2, and we solve it. So this is the answers we'll be getting, and we add it by V1 plus 2V2 plus 16, we'll be getting 24. Okay. Then this will be our first equation.
Okay.
Okay, now Tommy, we're going to use get the second equation. For the second equation, we'll be using KVL at the supernode. So what is KVL? KVL is the sum of voltage drop will be equal to sum of voltage rises. So here, V1 minus by V2 is equals to 12 voltage. So this is our second equation.
I see.
Yeah.
So I get what you mean right now. So in order to solve both equations that you have just explained just now, so equation 2 I must add with equation 1, right?
Yes.
Okay, so in order to solve this, I have to use a simultaneous equation, right?
Yeah, correct.
So, okay, I will multiply equation 2 by 2. So I will get 2v1 minus 2v2, okay, is equal to 24. And then I add in the first equation, which is v1 plus 2v2 equals to 8. So I will cancel out 2v2 and this both of this part lah. So when we take 2v1, we add v1, we get 3v1 is equal to 32, right?
Yeah, correct.
Okay. So in order to get the value of v1, right? So right now 3v1 is equal to 32. So I take 32 and I divide by 3, right?
Yes, that's correct.
Okay, so after I divide, the value of V1 is now equal to 10.67 volt. Okay, so after I get the value of V1, okay, I will have to substitute V1 into the second equation. Okay, which is V1 10.67 volt minus V2 equals to 12 volt. Okay, so using basic maths algebra. Okay, so 12 volt, we minus 10.67 volt, and then we get negative V2 equals to 1.33 volt. So in the end, V2 is equal to negative 1.33 volts. So this will be the final answer. Is that correct, Rugen?
Yes, correct. So the final answer will be V1 equals to 10.67 voltage and V2 equals to negative 1.33 voltage.
Well, I guess that's the end of our...
Yes, that's the end of our slide also.
Alright.